Hello friends, today we are going to see the simple beam analysis of a continuous beam. In that I have taken one beam which is having a 3 span which is continuous, and you can see the supports and having the point load of 5 kilonewton at the mid span for every span. So now we'll go to ETABS. We'll create a new file. You can set built-in setting or save user default setting, whatever you are requiring, and we'll select the blank option. As you can see, because we have to just draw one beam and analyze the beam. So to draw the beam we need to use draw beam command, which is having in the left ribbon option. So here we'll take a concrete beam, is already having default properties in the ETABS. Also we can start drawing by use first by grid, but here I am directly drawing the beam with the snap options. So here our beam length is 5 meter each, as you can see. After selecting the whole beam, you can see the 4 joints it's showing. So for this joint we'll now assign the support conditions. As we know, the continuous beam is a statically indeterminate structure, so our first support will be pin support, and here I am assigning the remaining support as a roller support. Here you can assign the next 2 supports as a pin support also, so there have no any problem. So you can see in the 3D view the supports have been assigned successfully. So this is the in plan view and 3D view. You can see the joints. As the beam property has been assigned, which is default, so we'll now go to assigning frame loads, and here as we are assigning the point load, so we'll select the point option. So here you can see in point load there are 2 options, relative distance and the absolute distance. Relative distance works as a ratio for the distance. Absolute distance is as per the distance exact from the load from left end to J end, is last. As the length is our 5 meters, so we'll assign the point load at midpoint, which is at 2.5 meter. So here our distance is 2.5 and the load is 5 kilonewton, and the direction of load application is already gravity, so we not need to give any sign conventions in the load. Same procedure will be followed for the remaining 2 spans. So as you can see here we have given the point load in the dead load combinations. You can assign this load in any other like brick wall or any type of load combination, which we'll see in the load pattern. As you can see, the load has been assigned successfully as per it's showing in 3D view. As you can see here, load pattern is dead and the point force, which is 5 kilonewton at 2.5 meter under gravity. Now we'll run the analysis. For that we need to save the model with the file name in the form of EDB file format. So here the analysis has been started and it will take a couple of seconds to run the analysis of a beam. Here it may contain some messages, warning messages. This message you can ignore, because here we are just analyzing one simple beam, not a whole structure. Now we'll see the BMD and SFD diagram. The moment in 3 direction will show the BMD for dead load pattern. Here you can see the moment at the supports will be negative and the midspan moment is the positive. By clicking the right option, you can see the detail, equivalent loads, shear, moment and deflection of a single span beam. So it will show the value as you scroll from the span from start end to the J end, which is the end of the span of beam. So for every span all the analysis results has been obtained. These results can be checked with manual calculation as well. Also in the equivalent loads it is showing the reactions at the support as well. So this is about the moment 3 direction we have checked. Also in shear in 2 directions we can check for whole beam. For your convenient you can draw the grid line and see the elevation of that grid, so you will get a shear and moment diagram at instance. Here one configuration you can also change, like if you want moment diagram on opposite side, so you can untick the moment diagrams on tension side option. but preferably moment diagram on tension side option is preferable. You can scroll on diagram as well to see the values at the controlling stations on diagram. So now we'll look for the support reaction for our load pattern dead. As we know in ETABS the vertical direction is FZ, so we'll check FZ tick and we'll see the support reaction. By clicking on joint also you will get the force which is indicating the support reaction. So other format like tabulated format also you can check if you want to note down the values. So these support reactions also you can manually check for the same loading condition. This is about the support reaction. So in this beam, as we have considered the default property of beam, so that's why it has considered the self weight under dead load of the beam as well. So to just check the analysis results for the net loading condition, we can make the self weight multiplier to the 0. It will not account for the self weight of the beam. So now here you can see only the analysis results for the net loading condition, which is our point load. For that only the moment diagram has been changed. So here the self weight has not been considered of the beam. So as there is no UDL acting, so the only point load SFD BMD we can able to see in the analysis results. So it applicable to all the beams, and these are the analysis results. And for beam we'll consider the deflection relative to beam ends option. Here you can see clearly where the point load is acting, the shear moment, the shear force diagram changing from negative to positive as the point of contraflexure is also visible. So as we know that in simply supported beam, where the shear force is maximum, bending moment will be 0, and where the bending moment is maximum, shear force will be 0. Also another option is that you can make the concrete property as a massless instead of giving the dead load factor as 0. This is also another option you can check to see the only net analysis of the loading condition. So after running the analysis you can see the results which are same for the previous conditions or not. So here you can see the values are matching with the previous condition where we have did the dead load pattern. So thank you so much for the watching. Kindly subscribe and share this video for basic understanding of a simple beam. You can also try doing many options, or you can try many types of beam and see the results with manual and the software output. You can compare the results as well. Thank you.